introduction of our next company and speaker, Natoli Engineering. Bill Turner, the Technical Service Manager of Tooling and Tablets. And it's a great honor for me to introduce you to Bill and Bill's knowledge and his true desire to help customers improve tablet performance is bar none. I mean, he's a spectacular guy. Bill represents unparalleled depth of talent in Natoli and his entire team. So, they're a valuable partner. You guys are a valuable partner here at Techceuticals. If you want to talk to Bill, he's the giant in our business, if you ask me. Bill, I'm going to turn it over to you. I want to welcome you and always interested to hear what you have to deliver to us today.
Well, thanks, Mike. Hello, appreciate it. Hello, everybody. Michael, thank you so much for that very kind introduction. And appreciate being online here. Thanks to Pharma Online. Thank you to you, Michael, for your introduction. So to get started with the presentation, I got to see if I've got control here. Okay, all right, here we go. Get right into the presentation here. I'm going to start off with a theoretical question. With today's tablet presses at maximum size, instrumentation, and speed capability, what's the next logical step for improving production on your floor? I'm going to suggest that it's multi-tip tooling. Multi-tip tooling has the capability of producing, obviously, more than one tablet per punch per stroke. All right, so this is me. I'm the technical service manager at Natoli. Been here for 43 years, a long time, like you, Mike, and 25 years spent as engineering manager doing tooling design, tablet design, and the last 18 years as technical service manager. And so what I would like to do now is talk about the details of the advantages and details of multi-tip tooling. Obviously, the idea here is to increase tablet production. How do we do that? Well, we do that by reducing the number of presses, tooling sets, and operators, and utilizing your existing equipment and facilities to the fullest extent. This will increase your efficiency by reducing your overall operating costs. So here's a nice picture of an assortment of multi-tip tools. If you look at this picture for a few seconds, you can see that we have large and small, different tablet shapes, different tooling types, all the way from a single station machine to the largest rotary machine, all has the capability of using multi-tip tools. There really are no restrictions at all when it comes to what is applicable to multi-tip tooling. All right, so the design considerations, what needs to be on your mind, you, the customer, what is on your mind when you're thinking about multi-tip tooling? Well, the first thing would be tablet size. Next thing would be tablet shape. Is it round? Or is it some other shape, capsule or oval or something unusual? Cup depth and cup configuration come into play. Tooling size, whether it's a B or a D tool, the most common, or some other tool size. And what punch type you prefer. There are two different punch types. I'm going to go through the details. I'm going to pause on this list now for a few seconds and go into the details of each of these two types of punches. The assembled punch design is where the punch tips are made individually and separately and attached to the body of the punch utilizing a specially made cap and some sort of fixing method, of which you see here is a roll pin that goes sideways through the cap and the body to fix it all together. All right, the solid punch design, also referred to as the monoblock, is the entire multi-tip punch is made from one piece of steel. All right, so there's some advantages and disadvantages to both designs, and I want to go through those real quick just to educate you on that. The plus sign shows the advantages, the negative sign shows the disadvantages. So for the assembled, on single tips, if any single tip tool is damaged, it can be replaced. The punch body can be designed to be universally reused. But the negatives are the potential for product dust or powder or cleaning solutions to migrate into the mating surfaces of the parts. Somewhat difficult to clean and maintain, and does require skilled technicians to disassemble, clean, and reassemble them. All right, the solid design, the big advantage is no assembly required, all right? They are one solid piece of steel. All right, there are no mating parts and crevices for product to get stuck into. They're easier to clean and maintain, and that's the primary reason we developed the solid type of tool. It may allow for more tips because now we have the entire body of the punch to work with instead of having any space taken up by the cap. May allow for larger tips. But unfortunately, damage to any single tip may result in scrapping the punch. So you can't replace individual components. Worn tips will require replacement of the punch, and you cannot reuse any component. And on the micro tab tooling, which we'll get to in just a minute, the solid version is not available. Only those can be made as assembled tools. Okay, so to continue with that design, we talked about the two different types of punches, solid and assembled. To continue on for your considerations, you might be thinking about granulation flow, because now each punch station is requiring multiple die bores to fill. We have to make sure we get all of them filled up, so we have to have good powder flow for that. I would advise you to not consider multi-tip tooling, especially the first time around, for a problem type of powder flow. Tablet ejection. I'm ejecting more than one tablet per punch now, so it requires a little bit more force to obtain that. Tablet takeoff. Orientation of the tablet shape, depth of the cup, and embossing on the lower punch face can all play a factor on how easy the multiple tablets take off. All right, so we're pushing out a question to you, and I'd like you folks who are online watching and listening to this to select, to read this question and select one of these answers. That would be great feedback, and we deeply appreciate that. All right, so back to the orientation. You see on the left-hand side, there's two possibilities of a medium-sized oval on a B-sized die with a triangular-shaped pattern. So what we're trying to do here is find the optimal position for all three tablets for takeoff. The pattern dictates that we have a triangular pattern, so really only one of the three tablets can be optimized for tablet takeoff. The other two will come off in an unusual fashion. But if the cup is not too deep, then this probably will work fine. But if you go over to the right-hand side of the screen and you see the diagram that shows only two of those oval tips on that same die, aligned parallel to each other and aligned parallel to the tablet takeoff, this would be the most optimal condition for tablet takeoff. Okay? All right, so how do we select the tablet press for multi-tip tooling? Well, consider the condition of the turret. Consider the condition of the press as a whole. The complexity and the cost of multi-tip tooling, the best idea is to use it on tools or tablet presses with new or like new turrets. This is very important. If you have a worn out machine, worn out cams, worn out turret, it's probably not going to treat your multi-tip tooling with the high regard that it's due. The number of stations of the machine, you know, is it a B machine, a D machine, and what type of station count the machine has? Obviously, the higher station count, the more tablets per hour you're going to get out of the machine. How fast the machine can run. You may not be running it at full speed with multi-tip, but you will be running it at an optimum condition that will produce a very high tablet per hour rating. The feeder type. There are two basic types in the world. There's the open feed frame, which requires gravity to pull the powder in, and then the other one is the paddle feeder or the force feeder. That would be the one to use for multi-tip tooling, the paddle feeder version. And on most paddle feeders, you have the ability to use a variable opening for the exposure of the powder to the pattern of the die. And of course, the paddle design can be altered to force powder into the die rather than just move it around and have it pull in by gravity or by suction. The tablet takeoff. It's nice to have a machine that has the ability to adjust the tablet takeoff, maybe even use air assist to blow small tablets off the face of the die on tablet takeoff. And do recall that a lot of modern tablet presses have reject system capability. This might be a little convoluted because you're making more than one tablet per station, whereas the station is responsible for sensing the force being applied on that station and assuming that the tablets are in weight or not in weight. All right, and a tailover die is a very good idea to make sure all that powder stays in the die bores. So a well-equipped machine is really what we're talking about here. All right, selecting the tablet press. We talked about both B and D type tooling, so let's just go through it real quick. A B-size tool can handle relatively small to medium-sized rounds, up to about 8 millimeter or 5/16 of a diameter. can handle very small to medium-sized shaped tablets like capsules and ovals and other shapes. We do require a small space between the cavities of the die bore for the strength and integrity of the die, usually around 2.5, maybe even 3 millimeter. And do recall for B-size tooling, there are two different size dies. There's a smaller BB die, 24 millimeter diameter, the larger B die. And I mentioned the smaller die because sometimes that restricts us in the real estate that's available for the bores in the die, more so than the larger B die. On the other side here, we have, of course, the D-size tooling, the larger tool. So basically, we have more real estate to work with. We have larger tablet capacity, up to 10 millimeter, about 13/32 of an inch. We can handle up to large size shapes now, capsules, ovals, and other shapes. We still require that spacing between die cavities so the die has integrity and strength. So what's the best basic tool configuration for multi-tip? Well, you know, we have our standard tools, and then we have the ability to add options to the tools to make them perform better or work better. We always recommend on multi-tip tools to either use the TSM domed head, or if you're in the European marketplace, you're going to have domed EU heads anyway. All right, so the key type comes into play as well. There are several different types of keys. The fixed parallel key is the most optimum, and is the one that we're going to want to recommend for multi-tip tooling. It's longer, it's rounded at the ends, it's easier for setup and easier for use. And dust cups. You know, most operators want to use dust cups on their tools, and there's two types. There's a tip-mounted dust cup, and there's the barrel-mounted dust cup. So we're going to make it easy on yourself. Use the barrel-mounted dust cup, which requires a small groove to be machined onto the punch, as you see here in the slide. So a few pictures of assembled punches. Here's a small heart-shaped tablet. Shows the uniqueness of what you can achieve with multi-tip tooling. This happens to be about a 1/4 inch heart-shaped 81 milligram adult aspirin tablet. So this is the assembled, and notice it has two tips on it. Also notice that the tips are held to the body with the cap screwed in place as opposed to pinned in place. And we'll talk about more about that as we go through. Here is an assembled type punch. This is a micro tab tool, 2 millimeter diameter on a D-size tool that holds 27 tips. So 27 tablets per compression stroke. All right, to alleviate some of the rotational torque that's going to be applied through the body of the punch into the tips from the lower side of the lower punch, we profess using what we call the rotating head design. In this design, the head of the punch is made separate from the body of the punch. It is held to the body of the punch with a couple of pins that capture that groove you see on that shaft that inserts into the body. This allows the head to rotate freely, independent of the body of the punch. Of course, the punch is not going to rotate because the tips are in the die. But what we're really doing here is removing any rotational torque that may be applied as the punch head travels through the cam track and over the pressure rolls that would be transmitted into the tips and could actually cause the tips to bind. Okay? Here is a blow up or an expansion of a multi-tip tool assembly type where you have the cap, the individual tips, the pin that holds it all together, and of course the rotating head. We have a new design for rotating heads we call the vented cap. I said rotating heads, I meant the cap. So we have the vented cap that allows you to assemble the tools and hopefully not have to take them apart when you clean. So you see the little slots around the vent of the cap. This means that you can clean your tool in your solutions, rinse it, and then blow dry the solutions out of the area where moisture can be entrapped. We have, if you do need to disassemble your tools, we have a kit to help you that. On the right-hand side, you see that kit. It has all the tools necessary to hold the tools and to drive the pin out, take it apart, and put it back together. On the left-hand side, you see a new innovation we have called the installation seal stop tool. So what this does is this actually stops the tool from its upward motion, the lower punch from its upward motion, so that the tips do not bang into the bottom of the die and become damaged. So it'll temporarily stop that motion once you get the barrel of the punch through the scraper seal on the machine, and then allow you to remove this tool, rotate the punch until you get that alignment, and then push the tool further up into the die. One nice feature for microtab tooling, if anybody in the audience is considering that, is to undercut the bottom of the die, allowing us to make the lower punch tips shorter than normal, which makes them stronger. All right. So this is a unique design. It is generally used only for very shallow requirements, shallow fill requirements, but this tool design does require that you use shallow fill cams, effective lower punch retainers to hold the punch up so the lower punch tips do not fall out the bottom of the die. All right. So it does require these features. Now, if you're a little squeamish and you don't like seeing wreck tooling, I want you to avert your eyes just for a second, because I'm going to show you what happens if you don't run the proper shallow fill cam and the effective lower punch retainers. Bang. What happened here is that lower punch dropped down out of the die, the tips disengaged from the die, the lower punch rotated a little bit, and then it forced back up on the next compression stroke, and it wrecked all of the punch tips. So heed the warning, always use the proper shallow fill cam. So here's a solid punch design for a little bit. This is that same 81 milligram aspirin, and notice that we have able to go all the way out to the outer diameter of the punch and actually put a third punch tip on there instead of only two. Here's a large round, 3 tips on a D-size tool. These are 9.5 millimeter, 3/8 of an inch. So you can see a lot of tableting going on there. Here's a large oval. It's about 8.5 millimeter by 17 millimeter. Again, a lot of tableting going on there. Another advantage of the solid multi-tip punch is that you can use our die alignment tool much as you would for any capsule or oval shape. We have an indexable, replaceable head for a situation where you have a compressible material, but it takes a lot of compression force and the head starts to wear. This tool is the head is indexable at 90-degree increments to quadruple the life of the punch head and then replace it if it is worn out over time. Misconception, it does not necessarily equate, doubling the tips does not necessarily equate to doubling the tablet production, primarily because you're probably going to want to run the press a little bit slower than optimized and then sneak up on those higher speeds. And that's to assure that we fill the tablet. Another misconception is that twice the number of tips do not necessarily equate to doubling of the compression and ejection forces. Studies have showed that there are certainly less than 100% increases in those values. So in conclusion, multi-tip tools are applicable to most small and medium round shaped tablets. Consider using multi-tip tooling on newer, modern, well-equipped tablet presses. Press and other equipment may require some modifications and operating at slower speeds. Larger investment in tooling, yes. Larger manufacturing time for tooling, yes. But of course, your big benefit is increasing the tablet production with less overall cost. So that's the end of the presentation. I open the floor to any questions. If there's any time left on the clock, Mike, I hand it over to you to see if there's any questions, but maybe not.
Hey, Bill, great. Thank you. You know, I really appreciate the pictures, the photographs, and the discussion on multi-tips. I think it's an incredibly important discussion. You know, I think there's a lot of folks that just simply, so the message, part of your message, or to me, is the technology of what you're doing. But remember that when we develop a formulation for a tablet, for making tablets, and we establish a speed, it's just not easy just to speed up a machine. That doesn't always mean you're going to be making more tablets at the same quality level. So if you had multi-tips, you're really not speeding up the machine and you're doubling production. If there's 2 tips, if there are 5 tips or 6 tips, just think what it does. And you've already formulated for the same RPM and dwell time. So you really get the benefit of production there. I guess that wasn't a question, Bill. It was just part of my excitement about what you're talking about. But I think it's a really good presentation. One question is, how many tips can I put? You know, you showed me multi-tips, micro-tabs. You showed me, how do I know, or how does somebody know how many tips I can put into a station?
That's a great question. It gets right down to the meat and potatoes of it. And what I would suggest is to have you contact us with your potential tablets. You are thinking about multi-tip. Let us know what tablet design or designs you're interested in, what equipment you have available for running them. Give us the opportunity to sketch up and see how many tips will fit, the patterns that we would suggest, offer a quote for tooling, and move forward from there. So a quick answer to that question is, please contact us. My contact information is on the screen. You can contact us through my email or through our generic email at info@natoli.com. Give us a call at our phone number. We'd appreciate that contact. And I want to thank the audience for your time today. It's been a pleasure being in front of you and introducing you to multi-tip tooling, and look forward to talking to you in the future. Mike, thank you so much.